Well, hello and welcome back from your weekend. I hope you guys remember how to do some expressions. We're going to do a quick little review of Lesson 9. So if you could open up your math books to S43, we have 7 problems we're going to look at and see what you guys can remember about some of these keywords. Okay, all right, so let's go ahead and look at number 1. It says to write 2 expressions. Remember, an expression is a mathematical problem that we write without an equal sign. And we have to show a number, and we have the word decreased by 11. We're not going to draw models, but we're going to go ahead and write an expression. Let's see, a number decreased by 11. Well, unfortunately, we can't write 2 expressions for that because a number decreased would be something like this. A number decreased by 11. We can't do it because, remember, subtraction is not commutative. So this one would have to say 1 expression. We could have made 2 if it was addition, because addition is commutative, but we can only do 1. All right, let's go to number 2. Number 2 says to write an expression to show the, here's our key word, sum of x and y. Sum. Sum means addition, and we are adding x and y. This would be an example of one that we could swap because addition is commutative. Number 3. Number 3 says to write an expression to show h decreased by 13. So this is very similar to the one we did up here. We have h, and we're decreasing it by 13. Number 4. Write an expression to show k less than 3.5. This is the one that tricks a lot of us. K less than 3.5. That would be k is less than 3.5. So the problem actually is 3 5/10. Subtract k. Number 5. Write an expression to show the, here's our word, sum of g and h. So we have here the sum of g and h, and it's going to be reduced by 11. Reduced. What would that mean? Reduced means subtract. Now, obviously, we're going to do the sum first, and even according to order of operations, we would do this first. We don't have to have parentheses. Sometimes people will add parentheses just to make sure that they know to do that first, but we already know to do that because according to order of operations, we do addition in this problem first because it comes first in our problem. Number 6. Write an expression to show 5, here's this trick one again, less than y plus g. Well, let's first of all do 5 less than y. So we have 5 is less than y. Then we have to add g. Once again, if we were doing the problem, we would do this first. According to order of operations, adding and subtracting go hand in hand. We would do whatever comes first in the problem. If you wanted to put the parentheses here, you can, but we would not have to because we already know to do subtraction first. Okay, like I said, we were just going to do some quick problems here. Number 7 says to write an expression to show 5. Oh boy, they like this. 5 less than the sum of y and g. So we have here 5 is less than something. What is 5 less than? 5 is less than the sum of y and g. Sum is add. So we write it like this. Once again, we know adding is first in the problem, so I'm going to do this first. But if you wanted to put the parentheses, you could, but you would not have to. Okay, so we did a lot of expressions with adding and subtracting. Today we're going to move on to the other operations of multiplying and dividing. So if you would flip your book over for me. Okay, so we're going to start with Lesson 10, and Lesson 10 is going to focus basically on multiplication expressions. What I'd like for you to do in this open spot is I'd like for you to write some ways that we can multiply. So for example, we're going to pick the integers 5 and 7. Most of us know we can write 5 times 7 with an x. We also know that a dot can mean multiplication. We also know now that, or maybe you haven't, but you can also do multiplying, for example, like this. Now, obviously, I can't do this because that to me looks like the number 57. And so when I have two integers, I can't write multiplication like that. Let's go over here and see. Let's try what if I have variables. Let's say I would want to do A times B. I could do A times B this way. I could also do A times B in parentheses. And the final way is because these are variables, I can have them touching like this without something in between, whereas I couldn't do with integers. That looks like 57, but this I know means A times B. Okay, so let's look at some of these expressions we have here. We have the expression 6 times B. We want to take these expressions and we want to be mathematicians and we want to make this as short as possible. What is another way that I could write 6 times B in a very short, simple way? I could do the dot, but that's not making it any shorter. I still would have three things that I'm writing. I could do parentheses. That might make it a little bit shorter. But let's look at this one. What if we put them touching like this? 6b. Okay, those are touching. One is a coefficient and one is a variable. Because they're touching, that means we're going to multiply. What I'd like for you to do is, if you were listening to my word, I said coefficient, we're going to actually label that number. All right, so let's go ahead and this is called a coefficient. So let's go ahead and write that word. Okay, so the number is called the coefficient, and obviously this here is called our variable. In case we forgot, let's label that as well. Okay, and what we are doing is we are multiplying and we are trying to find the product. All right, let's go ahead and look at B, something new here. All right, we want to make this as short as we can. What looks like to me, actually, we have two integers here that we could actually combine. We could actually do 4 times 3. 4 times 3 would be 12, and 12 times h would be just h. We now have 12 times h, which is the same as 4 times 3 times h. This is expanded, and this is not. The coefficient, remember, is the 12, and h is our variable. Ooh, let's look at C. Lots of similar things. We have integers here. I have an A here, and I have a B here. Okay, well, we can combine our integers. We can combine 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8. There's nothing we can combine the A with, so we'll put times A, and we only have one B. So our answer would be 8 times A times B is the same as 2 times 2 times 2 times A times B. Now, the other thing I want you to look at before we move down to D is, if you notice, I know that multiplication is what we would call commutative, which means I know that 12 times h would be the same as h times 12. However, when we write these expressions, we always put the coefficient first and the variable last. So we would not write it like this. And then this one, you notice I have 8ba. The other thing we try and do is we make sure our coefficient is first, and then we make sure our variables are in ABC order. So these are in ABC order, and these are not. So see if you can solve problem D for me. I want you to put your integers together by multiplying them, and then I want you to put your variables together in ABC order. All right, so your answer should be 5 times 3 is 15. And if you put them in order of ABC, M comes before P. So we have 15 times M times P is the same as 5 times M times 3 times P. Last one. What is the shortest way we could do this? Most of you are probably thinking we could write 1 G W, because G comes before W when we have ABC order. The other way that you could write this to make it even shorter is just G times W. And the reason why is because if I have G times W and I'm taking it times 1, will my answer change when I multiply by the number 1? It will not change, so I don't have to put that 1 there. All right, let's turn over to the next page. All right, so this time we're going to go the opposite direction. On the first page, we had the expanded form, and we came up with something shorter. Now we have the short answer, but now we want to expand it. So, for example, if I wanted to take 5 times G and make it a little bit expanded, I might go ahead and put 5 times G. Or maybe I would want to do 5 times G that way. Okay, couple ways to do it. Let's look at letter B. How can I make that expanded? Well, it says here, oh, we did say we have to use the dot. Let's follow the directions here, Mrs. Houck. Okay, so I do 7 times A times B times C. Let's look at C. Some of us are going to look at C, and we're going to do 12 times G. But is there a way I could make this 12 any longer? What could I do to make 12? What two numbers can I multiply together to make 12? I could do this. 3 times 4 times G. 3 times 4 is 12. I'm going to get this answer. Is there any way I could multiply 3 numbers together to make 12? So, for example, what if I took this 3 and then I noticed 4? 3 is prime, 4 is not. I could change 4 to 2 times 2. 2 times 2 is 4, times 3 is 12. And, of course, I'm going to put the G. If you look which one was expanded the most, I would say this one was our best choice. Let's look at D. 3H times 8. This actually means 3 times H times 8, so we could do 3 times H times 8. However, I'm looking closely, and I think there might be a way we could expand this one if we wanted to. What could we do to that 8? Oh, we could do this. We could change the 8 to 4 times 2. We could look here and look at this 4. We could even, this is a composite number, we can even change it to 3 times H times, let's see, what would equal 2 times 2? Oh, don't forget the dot here. And times 2 again. Oh my goodness, let's see what we have here. Let's see if I can solve this mess here. 3 times 2 is 6, times 2 is 12, and 12 times 2 is 24. 24H and 3. Oh, so that would work. So here's 3 different ways that we were able to expand that expression. All right, let's look at E. What can I do to E? Well, we could do 7 times G times 9 times H. That's one way. 7 is a composite. I'm sorry, 7 is a prime number. I can't find any two numbers that I can multiply to make 7 except for 7 times 1, and we don't want to put the 1 in our problem. Ooh, 9. I could change 9. I think 9 could actually be 3 times 3. So we would have 7 times G times 3 times 3 times H. So we looked at our multiplication problem here. We have an expression. We expanded that expression to make it longer. All right, let's move down to example C. Example C, we're not using the dot all the time. We're going to throw in the word product and multiply. When you hear the words product and multiply, obviously, we are going to continue doing multiplication. This one says find the product of 4F times 7G. Product means we want to find the answer to our multiplication problem. Well, let me rewrite this. I have 4 times F times 7 times G. Let's see. I could multiply these two numbers together, and 4 times 7 would equal 28. I have the letters F and G. Which one comes first in ABC order? F comes first, and then G. 28FG would be my final answer. Let's look at B. Let's see. I see some numbers here. I'm going to go ahead and write it out just so we can look at it a little bit easier, and I can write on my paper here. So I see the integers 3 and 9. If I multiply 3 times 9, I get the answer 27. Oh, 1, 2, 3, 4 variables. Can we put those 4 variables in order by ABC? Let's see, A, B, D, E, Y, Z. So 3DE times 9YZ has the product of 27 DEYZ. Kind of sounds like a foreign language, doesn't it? All right, let's look at the last one here, C. C says we want to double the product of 6Y and 3BC. Double, what would it mean to double something? So if I have 2 pieces of candy and I'm going to double those 2 pieces of candy, that would mean I would have 4 pieces of candy. So double means we're going to multiply it times 2. So that means we're going to take times 2 and we're going to multiply it times 6Y and 3BC. All right, let's look at our integers. We have 2 times 6 times 3. 2 times 6 times 3 would be, this would be 12. And then 12 times 3 would be 36. Let's put our letters, our variables here in ABC order. A, B, we have B, C, and finally Y. Okay, well, I hope everyone is understanding our multiplication expressions. Your teachers might do some marker board practice for those of you that are in class. Otherwise, I will see you all tomorrow for math.